On this one?
Yeah.
2, 2. So y equals x. That's just right here. And y equals negative 3x plus 8. I had that graph upside down. Negative 3x plus 8. So negative 3. And that, you can see that comes out when I went down 1 over 3, down 1 over 3. I hit that. And these are going to be all fairly nice like that. And then you just label the intersection, and that's the solution. And that's the only ordered pair that's going to make both of those equations true, isn't it? Okay, so if we actually plug, one more time, if we plug in a 2 here and a 2 here, it works. If we put a 2 right there, negative 3 times 2 plus 8, it equals 2 also, doesn't it? So that's truly the solution to the system. Okay? So, what other kind of things are we going to run into? Probably, for you guys, graphing something like, let me make that a 3. Graphing these. How do you want to do this?
Get y by itself.
Okay, you want to solve for y.
Yeah.
Okay, so how do we do that?
Minus 3x.
Okay, we subtract 3x from both sides of the equation.
Then divide by 2 everywhere.
Wait, divide by
Negative 2.
-2. Right, we can divide by -2. And those will cancel, and y equals -2. There's our y-intercept. And then plus 3/2 x. So we can solve for y so that we can see what's going on. We can see the y-intercept. We can see the slope. Now, you don't have to. You can simply do this. Hey, if x is 0, 3 times 0 is 0. That term doesn't matter.
Negative 2.
-2. There's the y-intercept, which is what we got, right? And then if y is 0, x would equal 4 divided by 3. 4 divided by 3, which is 1 1/3. So this way we would say the y-intercept's -2, and the slope is up 3 over 2. So up 3 over 2, like this. Up 1, 2, 3 over 2. I messed that up. I only went over 1. There we go. In this case, we would say, okay, 0, -2, same point. And then 1 1/3, 0. Okay, 1 1/3. Is that the same line? If the x-intercept's 1 1/3? It is, isn't it? Okay, so you can graph it either way, but you've got to be able to solve for 0 or solve for y so that you can, graph it, or just put 0 in for x and 0 in for y and graph it that way. Now, some weird stuff can happen occasionally. Let's say I give you this equation, y equals negative 3x plus 5. In this equation, y equals negative 3x minus 4. What do you know about those two lines as soon as you look at them? They're parallel. They have different y-intercepts. One's going through 5 and then down 3 over 1. One's going through -4 and down 3 over 1. So where's the intersection? Okay, so in this case you would say there's no solution. No solution. Okay, there's no intersection, there's no solution. Now it's hard to tell sometimes. One might be in slope-intercept form, and then the other one could be in standard form. Let's see if I can come up with, we'll just say, and at first, they might not, it's hard to tell they're parallel, but when you graph them, you'll be able to see what's going on. Right, Hat? Okay. When you graph them, you'll be able to see that they're parallel. Okay, there's no solution. You okay with that, Shannon? Okay. The other thing is, I can have two equations like this, but they're really the same equation, or they're equivalent equations. What does equivalent mean?
Same.
They have the same solutions, right? They have the same solutions. So if I graph both these, they're going to be the same line on the graph. We already graphed them, by the way. They're both this line right here. Okay? So, if you think of that as two different lines that are just drawn one on top of each other, how many different points of intersection are there? Infinitely many, right. So a case like that, there can be infinitely many solutions. So that's something you have to consider. They may be parallel, which means there's no solution. They may actually be the same line, which means infinitely many solutions, or more likely, they're going to intersect and you're going to get that one point that they have in common. This is solved by graphing. We went over it quite a bit yesterday, got it today. How do you feel? You got this?
No. There's an analysis I made about it.
Graph them, tell me where they intersect. That's it. Okay. Here we go. So this is actually chapter 5. 5.1.
Are we putting in our bell work today?
Yeah. Today your bell work's due. That should all be filled up.